Hello and welcome to another video. In this video we're going to be working on minimum time to make rope colorful. And in the problem you have n balloons arranged in a rope. You're given a 0 index string colors where colors I is the colors of the ith balloon. And you want the rope to be colorful. You don't want two consecutive balloons to be of the same color. So you want to remove balloons from the rope. And you're also given a 0 index array needed time, where needed time I is the time that Bob needs to remove the ith balloon. Return the minimum time Bob needs to make the rope colorful. So in this first example, you can see that like these two balloons are the same, so you're going to need to remove one of them. So you basically need to remove one of these two. And it's cheaper to get rid of this one, the one that takes 3. So you get rid of that one. And then it's fine because essentially you get rid of this and this is fine. So that's 3 seconds. In the second example, you don't need to do anything. And in the third example, same kind of thing. You need to remove one out of these. So you're going to want to remove the cheaper one. And you're going to want to remove one out of these. So once again, the cheaper one. So it will take you 2 seconds. And the constraints are 10 to the 5th. And there are 26 colors. So I don't know if I misread this or something, but I actually did a DP solution here. And I thought it was fine. And it passed everything. But then it got a memory exceeded, which was really weird. I didn't do like the space optimized one. I just did a normal memoization. So I'll actually talk about like how to do that, because I'm sure a lot of people when they see this problem are going to want to do DP, and then I'll talk about like the easier, or not easier, but just like more efficient approach. So the reason this is DP that I thought of is like every balloon, we basically have a choice to either keep it or remove it. So this is like a perfect scenario of DP. And the states were relatively easy to figure out, right? So essentially in this problem, basically for every balloon, you have a choice to keep it or remove it. So for example, like in this first one, you can either keep it or remove it, right? And you can keep doing that and keep doing that and keep doing that. And I was like, even if I remove something that, you know, like let's say here, even if I choose to remove some of these, this will just be a worse solution. Like I'll have one solution where I choose to remove nothing, and then I'll have one solution where I choose to remove some of these, and the solution that I choose to remove nothing will just be cheaper, so automatically DP will give me the best answer. And the way to do that is pretty straightforward. So for DP, you need, once again, 3 things, right? You need states, you need a base case, and a recursive case. So for the state, definitely not too bad to think of. So what do we need to know? We want to know the index where we're at, and the other thing we really care about is like, what was the last color of the last balloon, right? To know, like, do we have to remove it or not? So, yeah. And once again, you always want to be looking at the constraints here. So the index is going to be 10 to the 5th, and because color is only lowercase language letters, there's only 26 letters. So this is going to be like 10 to the 5th times 26, which should be totally fine. Base case with all these problems is just out of bounds, return 0, right? Like, for all these index ones, once you're out of bounds, either return 0 or return 1 if you're checking for like successes or any of that kind of stuff. And so the recursive case is, you pretty much have 2 options, right? You can remove or keep. And basically I tried to remove or keep, but the only thing you can't do is you can't keep a balloon if, so can only do this if previous balloon is diff color, right? That's why we needed this last color. And so you'd basically go to your index in the color and you'd say like, okay, if I remove the balloon, then I just need to add whatever the cost of to remove it. And then my new color is going to be the previous color that was passed in, right? So for example, if I call DP of, you know, like 1 and blue, and I remove my current balloon, then my previous balloon is still blue because essentially I had a blue balloon, right? Then I have my cur balloon. I remove my cur balloon. So then the next one, the previous of that, is still going to be blue, right? So that's what happens if you remove. And if you keep, it's straightforward as well. You would just do dp of I plus 1. And then if you keep, then the color is going to be the color of this current balloon, right? So it's going to be color of cur balloon. If we choose to keep it, that's going to be that. And we basically just like minimize these two. And like I said, we can only keep it if the previous balloon's a different color. And the way I initialize it is I just called something like dp 0, and then I just passed in something that doesn't exist, so I just passed in like a dot, and that would be totally fine. You know, you would add like one more state, but because there's only 26 colors, and this dot would add like a 27th color. I was like, that's totally fine. And so it literally said like passed everything and the memory exceeded, which was kind of weird. So that's kind of how you do a DP solution here, was you basically just have these states. Now there is a better way to do it, and it's a little less intuitive, and I'm sure most people went for DP, especially since the last few problems were in DP, and that is the greedy solution. And so this is going to be better. So essentially, it's going to look something like this. Let's just make an array of balloons just so we can demonstrate it. So just have an array like this with a bunch of balloons. This is a lot, so here we go. And we can just demonstrate it. Yeah, I guess we can just have like A, B, C as our colors. So we'll have like A. Maybe we don't actually need this many. So let's actually get rid of. Let's make it smaller. We don't need this many. There we go. Let's do this. Okay. So let's just say we have like A, B, A, C, A, B, A. And then we also need one more array, right? So we need one more array of the actual like what's the cost of these things, right? To remove this balloon. So let's make one more array of the costs. And we'll just say like 5, 4, 3, 5, 6, 7, 9, 8. Okay. So essentially what we are going to do is we are going to initialize what we really only need to know. We only need to know two things, right? It's kind of the same thing as this DP. We only need to know what was the color of the last balloon and how much does it cost to remove. So let's say we initialize this to this dot once again, just to make it so like the first balloon is never the same as anything. So we'll initialize to the dot and 0, and we'll have our results variable. And basically what we're going to do is we're just going to go through this and we're just going to check. Let's move this. Let's make it a little bigger. There we go. So we're just going to be checking for this balloon, is it the same as the last balloon we have? So obviously in the beginning, it's not going to be the same as the last balloon we have, right? Because the first balloon is never going to be the same as the last balloon we had. So essentially, if it's not the same as the last balloon we had, we will just update the last balloon we had to this balloon here, and it costs 5 to remove. Then we'll move over here. Now we're going to say this balloon is the same as the last balloon we had. So essentially, we want to remove the cheaper one and save the more expensive one. So the cheaper one is going to be 4, and we'll save this one. So our result, we will update that to be, we want to update it to be 4, right? We're essentially getting rid of this balloon here, keeping this one. And this is how much it costs. Then we move over to B. And we say, is it the same as the one before? No, it's not. So we can update this now to be B with a cost of 3. Then we're going to move over here. We're going to say this is 5. We want to remove the cheaper one, so we're actually going to want to remove this one, right? So this is cost of 3, so we will add 3, so that there will be a 7 now in this result. And because we removed this one, we are going to store the more expensive one now as our last element. And we will then move to an A. It's different, so we can update our B to be an A with a cost of 6. And then C is different as well, so we'll update C with a cost of 7. Then here we have a C again, so we're going to remove the cheaper one, which is going to be this one, and we will update our current one to have a cost of 9. So we're going to remove 7, so this will be 14 total. And we removed this balloon here. Now we move on to A with a cost of 8. And then we will move on to B with a cost of 9, which is different, and then A with a cost of 8, which is different. So all of these are going to be different. So essentially, these are the balloons we removed. And this basic greedy thing, all we really need to keep track of just what's the last balloon we have. And anytime we get the same one, we just remove the cheaper one and we save the more expensive one. And we keep doing that over and over and over. And then we just update with our new balloon if they're totally different. And that's basically it. So the greedy one's a lot easier. It's kind of the same idea as this DP, but you don't really need to have the actual whole DP. You can just save one balloon. But I think the DP should work. I am still kind of confused why that was a memory thing. I mean, I can like space optimize it, and if you want to code up the DP, you could also space optimize it. where if your dimensions are actually index and color, because index only increases by 1 every time, you can space optimize it to make your space only color, and that should pass. But this greedy one is obviously going to be more efficient because we are not using any space and it's just a one pass. So let's code up that. So essentially we're going to have like a last balloon, and we'll just initialize it to this dot because we want the color to be different than the current color we're on, and the cost doesn't really matter because we're going to update it anyway. So now basically we want to iterate through colors any at a time, and in Python, if you want to iterate them as like iterate on the same index, you can do something like this for color time in zip, and basically this will create a list of tuples, and it doesn't create any more space because it just makes like an iterator. So we can zip up colors and needed time, and you can put in more things if you wanted to, because these are going to be the same length. If you wanted more things, you could put them in here as well. So essentially this will create a list of tuples, and each thing will have a color needed time, and then you can destructure here. So basically if color equals, we also need to have a result variable, so let's make that. If color equals last color at index 0, that means that we want to, remember, we want to delete the cheaper one and save the more expensive one, right? So result plus equals min of time, and last at index 1 is going to be the time, and then last at index 1 is going to have the max of these two things. Right, so delete the cheaper one, save the more expensive one. And that should be it for that one. And otherwise, we just update our last to be this color and time. So, and finally return a result, and that should do it. Okay, and there we go. So pretty efficient. Yeah, and I'm kind of curious about what things, and this is kind of useful. You can look at like other solutions, what space they have and stuff. This is basically the same exact thing. Interesting. It might just be because I made this because this is an array. This is going to be in like the heap or something. But whatever, it's not going to be like. It's not going to be a big difference in these. Oh, actually, no, never mind. This is runtime. This isn't space. Can I even look up space solutions? I don't think so. Okay, yeah, I can't. Okay. Yeah. So anyway, that's going to be all for this problem. So let's just write the time and space for this one. And it's going to be O of n time because we're just looping through one time, and space is O of 1. So yeah, definitely wasted a bit of time doing DP, but it's still good practice doing DP. So if you are practicing DP, definitely encourage you to do this one. Doing DP, totally possible and decent one to practice. So yeah, otherwise you can do this greedy thing. But the thing is with the greedy solutions is a lot of them are kind of unintuitive and they are kind of all over the place. So if you do think of them, cool, but they're not like super. They're not a super standard like algorithmic thing, I would think. So they're not like super important to practice. But regardless, that's going to be all for this one. So if you did like it, please like it and please subscribe to the channel. And I'll see you in the next one. Thanks for watching.